Our presenters today are Carl Fligger, who has been PMY's Quadro product marketing manager for over 15 years and has vast experience and knowledge on NVIDIA Quadro GPUs. Andrew Vandergrift is also joining us from NVIDIA. He is the business development manager with over 30 years in diagnostic imaging and informatics. So without further ado, I will pass it over to Carl.
Well, thank you for the introduction, Tanya, and welcome everyone. We've got a lot to cover today, so let's dive right in. I've known John Petty since the 1990s. He's not given to hyperbole. Stating that NVIDIA delivered real-time ray tracing 5 years before he thought possible is significant. Ray tracing's photorealistic images advanced the frontiers of medical imaging, particularly in conjunction with Quadro RTX's AI capabilities. As noted computer scientist Alan Kay said, "The best way to predict the future is to invent it." Essentially, NVIDIA has. Let's join them. NVIDIA Quadro powers displays and medical imaging systems from ISO, GE Healthcare, AGFA, NEC, Siemens, and Philips, among others. From ultrasound to CT, MRI, or PET, Quadro has played an integral role, and PNY, working with NVIDIA, has supported these and other companies across North America, Latin America, Europe, Middle East, Africa, and India. In 2006, NVIDIA introduced GPGPU, General Purpose GPU hardware, and CUDA, allowing GPUs to accelerate embarrassingly parallel algorithms. CUDA became the dominant API for GPU high-performance computing. NVIDIA Quadro RTX, also known as Turing GPUs, add real-time ray tracing and AI acceleration into the mix, resulting in the greatest advance since 2006. RT cores simulate the physical behavior of light and materials in real time. Features like ray triangle intersection or BVH transversal improve performance by increasing efficiency. Multi-precision tensor cores take AI into the mainstream and offer incredible performance. Up to 8K display support with high dynamic range delivers the most accurate images ever. NVLink pulls the GPU memory of two RTX boards at 5 times PCI Express speeds and effectively doubles core counts for performance scaling in extreme use cases. The synergies realized by Quadro RTX enable new AI-enhanced medical imaging systems and applications. Physically based simulation of light interacting with real materials creates completely realistic images when visualizing complex organs or other body structures at 25 times the speed of prior generation Pascal GPUs and 30 times faster than any available CPU, or for that matter, foreseeable CPU. Tensor cores multiply 2 4x4 matrices, then add a third FP16 or FP32 matrix to the result by using fused multiply-add operations. Admittedly esoteric stuff, but foundational to artificial intelligence, deep learning, machine learning, and machine vision applications. From AI-assisted diagnostic imaging to Internet of Medical Things to smart hospitals and clinics, tensor cores do the heavy lifting to bring this feature about. Ray tracing and rasterized graphics benefit from advanced shaders like mesh shading, texture space shading, variable rate shading, and multi-view rendering. Let's take a closer look at these. Mesh shading utilizes cooperative threads to generate compact meshes, also known as meshlets, directly on GPU for consumption by the rasterizer. Applications dealing with high geometric complexity benefit from this approach, which allows efficient culling and variable level of detail techniques to be brought into play. Texture space shading exploits spatial and temporal rendering redundancy. By decoupling shading from the screen space pixel grid, TSS achieves high levels of frame-to-frame stability because shading locations do not move between one frame and the next. Temporal shading is important to applications like virtual reality that require greatly improved image quality, free of aliasing artifacts, and temporal shimmer. Variable rate shading lets the GPU allocate different amounts of processing power within the same frame to render disparate parts of the image. VRS focuses the GPU on the most important portions of an image and expends fewer resources on less relevant regions. Foveated rendering, when used with the virtual reality head-mounted display with eye tracking, places photorealistic imagery where the fovea, a small pit located in the macula of the retina, provides the clearest vision of all. Multi-view rendering increases the number of projection centers or views for a single rendering pass from 2 to 4. All 4 views are position interdependent and can shift along any axis in the projective space. This unique rendering capability enables new display configurations for VR and provides an extremely wide field of view. In the medical domain, VR applications range from teaching anatomy with virtual cadavers, design and ergonomic optimization of operating rooms, even advanced minimally invasive or robotically assisted surgical techniques. Spatially accurate acoustical simulation provides immediacy and real-world context as well. Virtual Link, an open industry standard for VR HMD connectivity, provides a single cable connection, USB Type-C, between the GPU and compatible HMDs. Greater GPU memory capacity directly translates into viewing even the most complex medical VR environments with full fidelity by supporting complex geometries, large textures, and fluid movement within multiple panoramas. The chart shows Quadro RTX 6000 and RTX 8000 GPU memory capacity compared to GeForce RTX and Titan RTX offerings. When life depends on it, the additional GPU memory Quadro RTX provides becomes a lifeline. We discussed tensor cores briefly, but NVIDIA is also a software company, so an entire software stack, NVIDIA Clara Medical Imaging, is available to take full advantage of advanced AI for medical imaging. Andy will be discussing this in considerable detail momentarily. Let's briefly cover how deep learning is impacting diagnostics and drug discovery. Gauge equivariant CNNs. Quite a topic. The human body is essentially a myriad of curves and structures, some quite baroque, sculpted by evolution. Convolutional neural networks, also known as CNNs, are inspired by the mammalian visual cortex. They're surprisingly adept at learning patterns in two-dimensional data, but when applied to images or models with irregular shapes, standard CNNs don't work well. They need to be lifted out of flatland, so to speak. Gauge equivariant CNNs, GCNNs for short, can detect patterns in 3D arrays of pixels on asymmetrically curved objects like brains, hearts, kidneys, lungs, or other organs. This exciting new technique borrows the concept of gauge equivariance from physics, ensuring that quantities and their relationships don't depend on arbitrary frames of reference, also known as gauges. By equipping GCNNs with assumptions about the data in advance, for instance that a lung tumor is still a lung tumor, even if it's rotated or reflected within an image, GCNNs can identify visual evidence of medical conditions using just 1/10 the data required to train other types of networks. To learn more, read 3D GCNNs for pulmonary nodule detection, available at archive.org. Drug discovery is also a critically important issue throughout healthcare and medicine today. In silico medicine, delivered generative tensor reinforcement learning, an AI optimized for de novo small molecule design, and found 6 novel inhibitors of DDR1, Discordian Domain Receptor Family Member 1, which facilitates the communication of cells with their microenvironment. The identified inhibitors target specific enzymes that catalyze the transfer of a phosphate group from ATP, adenosine triphosphate, the energy currency of all cells, to a kinase target implicated in fibrosis and other diseases. This took only 21 days. 4 compounds were found to be active in biochemical assays, and 2 were validated in cell-based assays. The lead candidate DDDR1 kinase inhibitor was tested and demonstrated favorable results in mice. From start to finish, the complete process only took 46 days, some 15 times faster than similar publicly disclosed pharmaceutical company R&D methodologies for similar compounds. You can learn more about this by reading Deep Learning Enables Rapid Identification of Potent DDR1 Kinase Inhibitors, available on the Nature Biotechnology website. Unfortunately, this paper is behind a paywall, but the good news is you only have to pay $24.99 to access it. 186 plus AI drug discovery startups are utilizing deep learning to identify drug candidates. The implications are clear. AI is already fundamentally changing the way drugs are identified and developed. Now let's turn control over to Andy for a deep dive on NVIDIa's Clara Healthcare Initiative. Take it over, Andy.
Thank you, Carl. NVIDIA, the modern engine of AI, has been at the center of AI since 2012. That's when the GPU-powered AlexNet won the ImageNet competition to spark the modern era of AI. Looking at the stack that's presented in front of you, bottom up, NVIDIA's unified GPU architecture is available in multiple forms: workstation, data center, or in the cloud. On top of that, CUDA-X AI computing platform is the engine of AI. NVIDIA's computing solution addresses the end-to-end development of AI, from data processing to AI model training, model deployment, on-prem or in the cloud. NVIDIA Tech is optimized for every AI model and framework. We compute all forms of AI, from machine learning to deep learning to reinforcement learning. There's an extensive software suite that's accessible for free in the NGC, NVIDIA's GPU cloud. Don't confuse us with cloud service providers. NGC is NVIDIA's software hub. With NVIDIA's extensive partner ecosystem, we're available in every CSP and from every computer maker. Our goal is to bring AI to everyone. Next. There's 3 major trends that continue to drive the adoption of AI in the healthcare industry. AI is coming at healthcare like a huge wave. Last year, over 70% of imaging research was on AI. That's expected to continue to increase in 2020. At NVIDIA, we have an Inception program. This program provides support to startups in all industries. Currently, we've got about 5,700 members. Nearly 800 of them are HC startups. The Internet of Medical Things, medical devices at the edge, are being AI enabled. The resulting improved efficiency and productivity will save billions and ultimately improve outcomes in the future. And at the edge, compute engine requirements continue to increase. Real-time needs of applications are growing. Companies are aggressively developing intelligent devices, and there's an increasing number of hospitals developing their own AI algorithms. All will accelerate the adoption of AI. Next. These 3 industry trends are complemented by mega technology trends. Today, monolithic software development is challenging traditional medical device companies to rethink their product development and business models. These companies are typically saddled with legacy code that's been around for years, sometimes decades. But to keep up with the pace of AI, development practices need to move to a cloud-native modular architecture. Next. As I said, AI is coming to hospital from all directions. And it begins with data. With AI, data is the new source code. This presents a huge opportunity for us to offer solutions that make data AI ready. Once it's AI ready, it can be harnessed to develop robust AI models. As an example, in the case of radiology, annotating high quality data is a huge challenge since it can be so time consuming. So as we think of democratizing AI, it's essential to offer tools to lower the barrier to development of AI models. I'll get to that in a moment. With AI, the hospital becomes the focus of all this innovation. There's thousands of AI algorithms being developed by new startups and ISVs to bring cutting-edge innovation to create the smart hospital. New devices at the edge will get smarter, smaller, and be AI capable. This will all come together to define the AI capable smart hospital. Next. To lower the barriers to adoption and development, NVIDIA introduced Clara. It's named after Clara Barton. She's the founder of the American Red Cross and a hospital nurse in the American Civil War. She saw a need and provided nursing training at a time when there really wasn't any. We see the same for AI. So Clara is NVIDIA's healthcare application framework. It provides tools to build, adapt, and introduce AI-based workflows in the hospital. It includes full-stack GPU accelerated libraries, SDKs, and reference applications for developers, data scientists, researchers to create real-time, secure, and scalable solutions. Let's look at some of the key tools in the Clara framework. I mentioned the challenge of curating image data. The AI-assisted annotation tool dramatically speeds the process of labeling data. Using the example of liver segmentation, with AIAA, the user identifies multiple points along the liver, bounds of the liver, on a single image slice. And the tool identifies the liver on all subsequent slices, making it extremely fast to go through various exams and patient data sets. If you don't have a model, it's not a problem. Clara offers various pre-trained models as a starting point. The transfer learning tool is there to speed up training and improve the performance of your model or the performance of one of our pre-trained models. Data privacy is another huge barrier to adoption. Providers need to maintain patient privacy and are reluctant to allow data to leave the premises. Federated learning is a powerful tool enabling you to develop and introduce a model in one location and deploy in multiple locations using different patient demographics to retrain the original model while keeping sensitive patient data private. So let's look at an end-to-end application for Clara. Next. We can envision radiologists and data scientists collaborating to build AI with tools like those offered with Clara. Radiologists bring diagnostic expertise, and data scientists translate inputs into AI-powered applications. Clara provides tools for data annotation, training, deployment. It's a seamless end-to-end framework for medical applications. Let's begin at the left of this slide with the key element, unlabeled data. We've already established annotating unlabeled data is a challenge, but high-quality annotated data sets are essential for training AI algorithms. The SDK includes APIs to add the AI-assisted annotation tool to any medical viewer. Simply download the SDK container from the NVIDIA GPU cloud. The next step is to train a model. You can train a new one from scratch or adapt an existing one using techniques like transfer learning and federated learning that we discussed earlier. Clara Train SDK allows you to do either since it contains pre-trained AI models and a Python-based library with APIs. This makes it simple to adapt and train models to new data sets. Now you're ready to make the model inference ready. Use Clara Deploy to export the model into your current medical imaging system so that it can seamlessly communicate in a PACS environment. This is made possible with containers and built-in support for DICOM. All Clara SDKs are supported for on-prem and in-cloud deployment. They're modular, so you can customize some features and capabilities or create new workflows. To get started, you can access Clara on our website. The link is at the top of this slide. And once you've tried it, we'd love to hear your feedback. We depend on user feedback in order to iterate on Clara. Next. So our goal is to enable the development, ultimately, of software-defined instruments. In a practical sense, if we look at traditional medical devices, a lot of algorithms are hard-coded in an FPGA implementation. This can make them hard to update and maintain. We've been working with medical device companies for over a decade with our GPU programming model. With AI, our mission is to enable software-defined instruments where the edge device is connected to and augmented by the compute capabilities of a sidecar, or even better, a supercomputer in a data center or in the cloud. This is seamlessly possible because NVIDIA's unified GPU architecture programming paradigm. The result will be faster innovation, more upgrade opportunities, and easier deployment and management. So now I'll turn it back to Carl to hear about Quadro Turing GPU stack. It features tensor cores for AI, RT cores for ray tracing, along with CUDA cores for compute. Carl?
Thank you, Andy. You know, before I do move on, I'd like to make a very important point. NVIDIA employs more software engineers than hardware engineers, and no other company is taking the time to develop environments like Clara to enable advanced AI, healthcare, and medical imaging applications. So when you buy into the Quadro ecosystem, you're not just buying hardware, you're buying an extensive assortment of tools, SDKs, developer blogs, developer support experts that can help you realize your goals for next generation healthcare within your organization. Available nowhere else but NVIDIA. That said, let's briefly cover the Quadro product line before taking a closer look at the RTX series products. Entry Quadro boards like the P400 or P620 are ideal choices for driving medical diagnostic displays. They support DICOM, digital imaging and communication in medicine calibration, and DDC-CI/MCC over DisplayPort's auxiliary channel. The basic class Quadro P2200 is an ideal choice for ultrasound systems, including display and imaging processing, even ultrasound beamforming, thanks to CUDA-enabled compute capabilities. The P1000 is also suitable for this use case. Mid-range choices include the RTX 4000, with all of the real-time ray tracing, advanced shading, and AI capabilities previously discussed. The Quadro P4000 remains available and is utilized across many CT, MRI, and PET systems. Upper range offerings significantly boost GPU performance, double available GPU memory, and the Quadro RTX 5000 adds NVLink performance scalability to the real-time ray tracing, advanced shading, and AI capabilities offered by RTX series products. The form factor moves to dual slot width, and the Pascal architecture P5000 remains available. High-end boards continue to offer considerable improvements in GPU memory capacity and performance, and double NVLink interconnect speed. The Powerhouse RTX 6000 is an ideal choice for sophisticated 3D medical imaging applications enhanced by AI. For the first time ever, the RTX 6000 is available in actively cooled, fan sync, or passively cooled heat sink variants, a first for Quadro products. For legacy systems, the P6000 continues as part of this product segment. Ultra-high-end offerings are the most capacious and highest performance products NVIDIA currently knows how to build. Unprecedented GPU memory capacity and GPU performance are capable of real-time motion 3D medical imaging and offer the highest possible AI aggregation inferencing at the edge options currently available. RTX 8000 is also offered in actively or passively cooled versions, and the Tensor Core-equipped GV100 remains available if hardware FP64 is required. Now let's go into specific technical specifications for the various RTX products, starting with the RTX 8000 Active. 4,608 CUDA cores offer stellar graphics and compute performance. 48 gigabytes of GDDR6 GPU memory with optimal ECC, an industry capacity first, can hold even the most complex geometries, textures, materials definitions, lighting, and other essential information in GPU memory. 10 gigarrays per second realize real-time photorealistic ray tracing. On the compute front, 16.3 T-flops of FP32, 32.6 teraflops FP16, and 261 TOPS of Int8 essentially provide a supercomputer on a PCIe card. Back in my days at Apple, I could sell a half-height server stack that couldn't even provide a fraction of the performance a single Quadro RTX 8000 offers. 130.5 tensor teraflops are available for sophisticated AI-enabled functionality. 624 gigabytes per second of memory bandwidth ensure the GPU is never data starved, and NVLink allows two Quadro RTX 8000 boards to communicate bidirectionally at 100 gigabytes per second, 5 times PCI Express speed. 8K HDR, 6K HDR, 5K HDR, 4K HDR, essentially any display, projector, or VR HMD can be driven to its full potential. Now the RTX 8000 passive. The key GPU specifications are unchanged relative to the RTX 1000 active, as the table notes. On the compute front, 14.9 T-flops FP32, 29.9 FP16, 238.9 TOPS of Int8 are available. 119.4 tensor teraflops allow AI-enhanced applications of such sophistication they actually seem like assistants. Total board power drops to 250 watts, and passive cooling makes this board compatible with any system chassis qualified for dual slot with NVIDIA Tesla products. 100 gigabytes per second NVLink is also supported. For graphics, Quadro Virtual Data Center Workstation software brings the power of Quadro to hospitals and clinics using devices ranging from tablets to notebooks or desktops without installed Quadro GPUs. Just downstack, the RTX 6000 GPU specifications are unchanged from the RTX 8000 active, and compute, FP16, Int8, tensor teraflops performance are also identical to the RTX 8000. The defining difference is GPU memory capacity, 24 gigabytes of GDDR6 with optional ECC. NVLink remains at 100 gigabytes per second bidirectional, and display output capabilities are identical to the Quadro RTX 8000 active. The Quadro RTX 6000 passive, again, most of the specs are unchanged relative to the RTX 6000 active board. Compute numbers change somewhat, 14.9 teraflops FP32, 29.9 teraflops FP16, 238.9 TOPS Int8, and 119.4 tensor teraflops. Total board power remains at 250 watts, and again, passive cooling makes this board compatible with a wider array of system chassis than the actively cooled versions. 100 gigabytes per second NVLink is available, and Quadro VW Virtual Data Center Workstation is also supported. I should note, however, that the active products also support Quadro VWS and GPU virtualization. You've undoubtedly noticed that the teraflops and TOPS numbers differed between the active and passive versions of the Quadro RTX 8000 and RTX 6000. This table summarizes the results. Peak FP32 performance drops 8.6% when going to passive, FP16 8.2%, Int8 8.4%, and tensor teraflops down 8.5%, again when using the passive variants. Why? Differences in NVIDIA's GP Boost technology parameters and a requirement that total board power never exceeds 250 watts. Consider these performance deltas when choosing which version to utilize in a given use case. The passive boards are optimized for data center or cloud deployment, but the active cards can be used as well and are fully certified by NVIDIA for this purpose. Passive boards work with a wider array of server systems, but purpose-built GPU servers are available for their active counterparts. Ultimately, if you need every last cycle of performance, the active option is probably your best choice, but quite frankly, either is superb. The RTX 5000 remains a formidable choice for AI-augmented medical imaging and other healthcare applications. 3072 CUDA cores provide outstanding compute performance. 16 gigabytes of GDDR6 with optional ECC, again, accommodates the geometries, textures, materials, lighting, and associated metadata completely in GPU memory for very complex models, images, or AI analysis and inferencing. 8 gigaarrays per second drive real-time photorealistic ray tracing, and you see the teraflops, FP16, FP32, and int8 performance numbers as well, and 89.2 tensor teraflops for AI-enabled features or functionality. Bandwidth is sufficient to keep the GPU busy, and NVLink allows two RTX 5000 boards to communicate bidirectionally, but at 50 gigabytes per second, 2.5 times PCI speed, which is half the rate of either the RTX 8000 or 6000. Again, any 8K, 6K, 5K, 4K, Full HD, HDR displays, essentially any display projector or VR HMD are supported by this card. What if you require Quadro RTX performance, but can't utilize a PCIe board form factor? PNY is bringing an NVIDIA Quadro RTX 5000 MXM 3.1 Type E product to market in spring of 2020, based on the powerful Quadro RTX 5000 mobile GPU. Some preliminary specifications are given here, with more shortly to come. At introduction, this will be the world's most powerful GPU available as an MXM, and PNY is the only NVIDIA authorized supplier of Quadro MXM products around the globe. With outstanding graphics, compute, and AI performance, 5-year lifecycle availability, and the ability to design custom thermal solutions, this uniquely capable MXM will find its way into many innovative medical devices. To get early access to information on this exciting product, email mxm@pny.com. NVIDIA's Quadro RTX 4000 is quite simply the world's most powerful single-slot width professional graphics board. Still has real-time ray tracing, the advanced shaders, AI acceleration. Nothing has been left out. 2,304 CUDA cores deliver excellent compute, and 8 gigabytes of GDDR6 handles complex images, models, or AI inferencing. 6 gigaarrays per second power the photorealistic ray tracing, and you see the FP32, FP16, and int8 TOPS numbers as well, which quite frankly, if you compare them to the prior generation Pascal architecture or AMD offerings, are simply unmatched in its form factor. 416 gigabytes per second of memory, again, keeps the GPU occupied, and any type of display from 8K to Full HD, high dynamic range, VR HMDs, projectors, all can be easily driven by this sophisticated, versatile, and extremely cost-effective card. So Quadro or GeForce? It's essentially a perennial question, yet the answer remains the same year after year. Quadro is rigorously optimized for the needs of healthcare and medical imaging workflows. GeForce is tuned for gaming. Quadro offers greater GPU memory capacity than GeForce and features like GPU Direct, which allows you to move massive amounts of medical imaging or AI data into the GPU with extremely low latency. It also offers a level of multi-GPU support unavailable with GeForce and other features. Given the regulatory and certification environments healthcare and medical imaging vendors must work within and hospitals and clinicians must abide by, long life, stable drivers, a rigorously controlled NVIDIA BOM, manufacturing and QA standards, even locked BOMs and custom view BIOS options are available with Quadro, but not GeForce. ISV certification lets you add third-party applications with confidence, knowing they will just work, or in the unlikely event a bug is found, that it will be fixed with Quadro. And in fact, PNY and our field application engineers have access directly to NVIDIA's bug reporting system for this purpose. With GeForce, if you encounter a bug, unless it affects a popular game, it's not going to get fixed. From an IT perspective, Quadro just fits in. Windows management instrumentation is baked into the Quadro driver. GeForce? No. Ease of IT management, global support and warranty, extended product availability, custom BOMs, custom vBIOSes. Quadro offers what you need to improve patient outcomes. That's essentially the slide portion of the presentation. Andy and I have covered a lot of ground today. If you want additional information, please visit pny.com/Quadro or send an email to gopny@pny.com and we'll answer any questions you have. Now let's turn to questions submitted by chat, and then, if time permits, take questions over computer audio or the phone. So, Tanya, do we have any questions queued up via chat?
Yes, we do. Thank you, Carl. James asked, he said, you mentioned kidney. Lithography is using sound. So can this improve the image of seeing the stones to be destroyed? I think that's an Andrew question.
Yeah, James, I don't know the answer to that, but my feeling is I could check with some of our various startups that are actively engaged in this area. I'm thinking that an ultrasound may be the best means of actually applying AI to do just what you're saying. If you want to provide your email address to PNY, I'd be happy to follow up with you to see what's being actively done in that area.
Yeah, please submit that to gopny@pny.com, and Andy and I will work through it. When I mentioned beamforming, it was a shorthand for saying a GPU can be an extremely sophisticated digital signal processor. So if in some sense the GPU could be used to modulate the beam of sound to optimize its ability to, dissolve or pulverize kidney stones, I think everyone, especially my younger brother, would be extremely grateful.
I'll move on to the next question. Does Clara have any support for non-medical CT imaging data, e.g. industrial micro CT? Is the platform available for non-medical use cases?
Simple answer to that is no and yes. Clara is NVIDIA foundational technology specifically focused in healthcare, but this foundational technology is also being applied to other industries that we're actively engaged in. And what I'm happy to do for this individual is to point you in the direction of one of my counterparts in the manufacturing area. I'm sure that they can speak to you more about how the various tools in the Clara framework are being focused in that area.
Yeah, developer.nvidia.com is a gold mine of information on tools for other markets like manufacturing or media and entertainment or architecture, engineering, and construction, in addition to healthcare, which is the focus of today's webinar.
Thank you. We have another question from Robert. Software-defined instruments allow faster innovation, but also expose device vulnerabilities to cyber interference. And in the IOMT world, are there AI-informed best practices?
Yeah, this is a great point. Within the NVIDIA stack, edge stack, we have a security component. And while I'd say best practices are just being created today as we work with our various customer partners, this is something that's an area of extreme focus just because of the challenge of what the problems that this could create.
Thank you. Ricardo asks, what is the main difference between the RTX 6000 and the Titan RTX cards? Carl, I think that's for you.
If you look at the hardware specifications, they're quite similar in a lot of ways. However, there are significant differences that are opened up by the Quadro driver. I mentioned one of them specifically, GPU Direct for video. These are features in the Quadro driver that allow you to move data from a system onto GPU memory for processing with extremely low latency. They're not supported on Titan RTX. If you're looking at it from an IT management perspective, you need to go in and analyze the health and performance of these cards to do failure prediction and possibly swap out a unit in a critical system. The WMI support is available on the Quadro boards, not available in the Titan cards. Again, if you look at the gross stats, fairly similar. And in fact, NVIDIA is positioning Titan as perhaps a good development option. If you want to dip your toes into Clara, for example, and you're interested in medical AI, it could be used as the development system, but then NVIDIA would request, in fact, the end user EULA agreement, the EULA, would require that you deploy on Quadro due to the build standards, the rigorously controlled BOM, the extensive driver support and additional features in the driver. So again, Titan plays a role, but when you deploy a production system in a highly regulated environment, you'll probably find Titan simply isn't the best way to go, unless you enjoy recertifying the system frequently.
Another question from Ricardo. Is special software needed to use to full potential the NVLink configuration?
I can take that one. An application does need to be NVLink aware. Developer.nvidia.com provides all the documentation you'd ever need to support the application to enable GPU pooling and equitably spread tasks across the CUDA cores, RT cores, Tensor cores in 2 cards. It's not what I call a heavy API. So to adopt NVLink is on a development scale. I won't say it's trivial, but it's a relatively simple process.
And Ryan is asking, can Quadro be used near high Tesla MRI machines?
Could you say that one again, please?
Sorry, can Quadro be used near high Tesla MRI machines?
By high Tesla, we're probably talking about the fields generated by the equipment. That would be a function of making sure that the Quadro was properly isolated from any transients or surges that may occur. In essence, a decent Faraday cage type design would probably preclude that. We presently have folks that use Quadro products in those types of products as part of the imaging pipeline. So it's being done today. It just involves some engineering to shield the board to ensure that imaging equipment doesn't generate any transients or signals that could possibly interfere with its operation.
Yeah, Carl, I can add to that. I agree. My experience is that you know, any of the GPUs, whether they be Quadro or even Tesla GPUs, would be located in a cabinet in an area that's outside of the actual MR suite, or in some sort of enclosure right in the technologistic imaging room.
Thank you, Andrew. Tyler is asking, are there good examples and or resources out there where we can use an existing hospital as the president currently using the Quadro card for imaging?
I can take this one, Carl. As far as good examples, what I would do is direct you to our website, where we show various use cases within medical imaging that may you know, give you ideas to be more specific to your actual question. We work with mostly academic centers, and if you want to send this question to PNY and direct it to me, I'm happy to talk to you more about what your application is and what the needs are, and see if there's something we can do to make an introduction. And
let me also, on this point, if you can send something to gopny@pny.com. Back in 2009, I experienced fairly severe diverticulitis, and the hospital I was at, which was part of the Sutter healthcare system in Northern California, was utilizing a Quadro equipped CT scanner that helped save my life. So I could potentially point you at, some local resources, but some permissions may be required. But I'll do what I can.
We have a question here from James. What VR manufacturers does it work with the best, or is it targeted towards?
We're Switzerland. We don't care if you like HTC. We don't care if you like Oculus. We don't care if you like some of the other smaller vendors that are offering extremely high resolution or wide field of view headsets. Between the hardware capabilities of the Quadro card, Virtual Link, the VRWorks developer toolkit, again, yet another example of NVIDIA easing the way for development and support of emerging technologies, we can support any of them. So basically, I'll say it's your choice. Choose the one that's most suitable to your use case, and you will find all kinds of support, either at NVIDIA or within PNY and our FAE team, or from the vendors themselves that realize Quadro is the go-to board for VR in professional environments that can help you integrate it, the HMD of choice.
Thank you, Carl. That is the question so far. I don't know if you want to open it up. If you have a question that you would like to ask, if you just look at the participant column, you will see there that you can raise your hand. If you raise your hand, Jay will unmute you so you can ask your question. And if there's no questions, Jay, I'm not seeing any hands raised. So
actually, we do have a band. You are if you unmute yourself, you are allowed to talk.
I actually see a question that came in via chat that we didn't take. Two cards, P4000, RTX 4000 have the same price, but RTX 4000 is much higher technology. Why pricing is the same on Amazon or Newegg or others? The simple fact of the matter is, Quadro cards are not produced in the massive volumes GeForce. We certainly, P4000s, thousands and thousands per month are sold and produced. But the fact of the matter is NVIDIA's gotten very good with their partner TMSC at process technology. So it was simply possible to pack more features into the RTX 4000 and bring it to market at a comparable price point. Now that begs to the question of why is the P4000 still available? Well, one of the points I made is long life cycle matters. If you integrate a card like the P4000, and I can guarantee you many major players in the medical imaging space have within their systems, they can't constantly be taking that card out, putting in a new card, requalifying, recertifying the system. So it does cost NVIDIA and PNY additional money to keep products on the market for longer life cycles. There's also the support model for Quadro, where we have a staff of field engineers, where NVIDIA has FAEs, where NVIDIA also has solution architects, where the Quadro driver is significantly more sophisticated and offers features simply unavailable in the Quadro driver. And all of that results in what are known as NREs, non-recoverable engineering expense. So the cost of a Quadro card isn't just the cost of the PCB, the traces on that card, the memory, the GPU, the thermal system. It's all the software engineering, all the support over the life cycle of ownership that goes into it as well.
And actually, Carl, we did get another question as well. What is the biggest differentiator between NVIDIA and your competitors in the medical imaging arena?
Boy, either one of us could take that. I'll let Andy take a shot, and then I'll take a shot as well.
Yeah, I'm kind of biased, obviously, but Carl, you mentioned something earlier in the presentation that spoke to the number of software engineers that we've got on board, and just the sheer number of folks that we have focused on software as opposed to any other function that we actually perform. And I'd say that's our driver technology and software is what distinguishes us most from the other companies in this space.
Yeah, I completely agree with that. In fact, you could go to, let's face it, today the competition is AMD, and they've been on a tear in the CPU space, but go to the website and try and find something like NVIDIA Clara. Go to the website and try and find something like VRWorks. I could do this for other markets. It just goes on and on and on. NVIDIA takes those software engineers and provides the tools companies or institutions or universities need to do the fundamental research to bring products to market, to deploy them widely, to make a difference. I'll use rendering as an example. NVIDIA has worked with an endless number of ISVs. All of the major photorealistic cinematic quality renderers support RTX technology. AMD's approach, well, here's this open source thing, go have fun. Look at AMD's product lineup. None of their products have anything analogous to an RT core for real-time ray tracing. None of their products have tensor cores to accelerate the foundational mathematical operations AI depends on. So I work for PNY. We are closely affiliated with NVIDIA. In fact, we're their master channel partner throughout North America, Latin America, Europe, Middle East, and Asia. I guess I bleed green too, but quite frankly, that's because it's simply the best solution with the best support, the best ecosystem, and the most business options for the developer and manufacturer community in the healthcare space.
Carl, we have another question from Kirk. As the Kepler and Maxwell generation cards are aging out of support, any guidelines on future support timelines on Pascal generation cards?
That's an interesting question. The only Pascal architecture cards so far, the Pascal cards so far that we've seen EOLs for are the P2000, but the P2200 is already there to replace it. On average, Quadro will have a product life cycle of 3 years. Some go longer than that. I had one card go literally almost 8 years. It was almost like losing a pet when I had to take that product off the market. But when it comes to the remainder of the Pascal product line, I would expect those boards to be available throughout the balance of calendar 2020 before transition to RTX technology occurs. And of course, the RTX product will have a similar life cycle. One point I didn't get a chance to talk about based on the condensed timing of this webinar is we offer an extended lifecycle program that will allow you to take select Quadro cards beyond even 3 years. So if you had a need for a longer life cycle, say 5 years, we can work with you to provide that. And when it comes to MXM embedded products, our default jumps from 3 to 5 years.
And yeah, Carl, I think there was one comment on here about addressing PNY's long life cycle program.
Again, that's something I would encourage you to use the gopny@pny.com email address. Our sales team can, work with you to qualify the opportunity, determine the number of cards. There can be costs associated with that, obviously, because NVIDIA needs to make additional components available to manufacture boards. PNY needs to purchase them. They need to be stocked. We need to be able to repair them, provide software support. So again, that would be an excellent use of gopny@pny.com, and we could enter into discussions and try and develop the best possible fit of the extended lifecycle program for your needs.
And just one, thank you, Carl. Just one adder to that around extended life. The majority of the boards in the Quadro stack that we've talked about, or actually all the boards in the Quadro stack that we talked about are traditionally available in long life, even some in the mid-range stack. So there, with our experience in medical, there's a recognition that these devices take a while to develop. There's also a life in the field that could be up to 5 years. So there's a need to actually offer these boards longer than our traditional life. So it's something that we're accustomed to, and we work very closely with P&Y to address any specific needs or unique needs around long life.
There's one last question here. I'm not quite sure if I'm going to say this correctly. Carl, can you see the last question on the Q&A? It says future product cards Quadro is PCIe 4.0 and cooperated with NVIDIA with Matrox. I'm not sure what that question.
Well, I think we can draw. Let me use this massive amount of wetware between my two ears and see if I can do some inferencing here. Hopefully, I can match an AI. Obviously, the PCI standard evolves. I mean, we started out with PCI 1.0, went to 2.0. Currently, most of the industry is on 3.0. 4.0 has been defined, and is new CPUs and their integrated logic support chipsets start to implement PCI Express, they'll move to 4.0. I can't divulge publicly a timeline for NVIDIA to do that. That would be non-disclosure information, so just can't go there. But I can assure you that NVIDIA participates in these standard bodies, is well aware of timelines, knows what's going on in the system vendor space. They work with all of the global tier 1 OEMs. They work with Intel, they work with AMD, they work with P&Y's extensive ecosystem of system builder capabilities. So it's fair to say that when appropriate, Quadro will, at some point in the future, move to PCI Express 4.0. Although the boards will be backward compatible, as they always have been, with prior implementations of the standard as well.
Well, I would like to thank both Carl and Andy for their presentation today. And as in the words of one of the attendees in the chat, the future with this technology is amazing. So again, thank you all for your time. And we will be sending out an email with a link to the presentation in the next couple of days. So again, thank you. And this concludes the webinar for today.
Thank you, Tanya. Thank you, Carl. Bye-bye.
Thank you, everyone. We appreciate your time, and a special shout out to Andy and Tanya. Thank you both.